Okay. Let's get out the notes that we had started the other day. If for some reason you misplaced yours, here's an extra copy up here. So there's $5 someone owes me. There's another $5 someone owes me. Anyone else need a copy of the notes? If not, get them out. J, letter J.
It's J.
It's J. I think I don't know why I'm I. All right. Okay. Excuse me. So, this is a continuation of J. We had done up to number 5. Yes?
Yeah.
Cool. Few things for this week for you to strongly think about. Some of you have emailed me saying, hey, it'd be better for you to take the capstone after break versus before. Okay. It just might be a little bit more on your plate after break. Realize when we get back after break, that period of time starts moving pretty quickly. So I saw that quite a few of you have gotten the Schoology portion done, and you got 10s on it, so congratulations. I would strongly encourage you prior to you. Huh? Well, the one on Schoology is the review. The one on Illuminate we do here.
Okay.
So, yeah.
The Schoology, how many attempts did you get?
I think I gave you up to 10. It takes the highest score. Cool. So, I would strongly encourage you, if you have the opportunity, please come see me on your off period, whether I have a class or not, so you can get that Schoology capstone done. And then remember, if you get a 7 out of 10 on it, I put a 20 out of 20 for a quiz score in, and then any improve over that, 8, 9, or 10, means that I take a look at your grade come the end of the semester and give you a little extra influence and inspiration and all those kind of good things. So those are things I would encourage you to do. But let's get those notes out from last time. J, and again, if you misplaced your J notes, I have extras up here if you can come grab one if you'd like. But let's start with number 6. So remember on these, we are you got to look at the domain and range. And the nice thing is right now we're not doing composite functions. So unless something really weird happens with the inverse, our domain and range just should flip-flop. They should. So taking a look at the first problem. Let's just do this in calligraphy pen. We'll go with that one. Okay, so domain of this one, we can plug really anything in. But when we plug negative values in, remember e to the first power is about 2.7. So anything that you plug in for e, your range is going to go from 0 to infinity. That's what our original is going to be. When we go find the inverse of things, we change the functional notation to y, flip-flop your x and y, and solve for y. So I divide by 3. And then the thing that undoes e is natural log, because those are inverse functions of each other. Might want to put that in parentheses just so you know that the natural log of the fraction is taking place, not the natural log of one or the other. And so my answer to this is going to be natural log x over 3. Our domain and range on this one should just flip. So our domain should go from 0 to infinity, while our range goes from negative to positive infinity. It's kind of hard when you look at your graph to see it going to negative infinity, but it's because your graph, as you approach your 0, so if you put like 0.000001 in for your x value, you'd get a really negative number. That's why the domain and range flips. So this is our answer to that one. Okay. As you get to number 7, it looks like our domain and range. Our domain on this one will go negative to positive infinity. Our range, as we plug really negative numbers in, we get 1 over 6. So then you multiply 1 over whatever 1 over 6 is, or whatever that 1 over 6 raised to a power, real small fractions, multiply it by a third. So this will also go from 0 rounded bracket to infinity. Flip-flop your x and y. Well, first off, change functional to this. Flip-flop your x and y. And start solving it. So multiply both sides by 3. And then on this one, we can do one of two things. We can do one of two things. We can either, what brings an exponent down front? And the answer is log, but also natural log does. So it's your choice if you want to use log or natural log. It doesn't really matter in the math of it. Usually if you don't see an E, you stick with log. But if you put natural log, it'd be okay as well. So on this one, I'm going to get log base, or 3x equals y minus 3. That comes down front. Log 6. Divide each side by log 6. And then I get y minus 3. Add 3 to both sides. So this is my inverse. Okay? Now, some places might ask you to do this. By definition, log base a of b is equal to log a over log b. So that goes backwards and forwards. So I might say that this would be the answer. Plus 3. Plus 3. So I might take that right there as an answer. Which one do I prefer? I think either are totally fine. I don't think there's one that's more correct than the other. Some might want to have it cleaned up a little bit more. And then if we look at the domain and range of this, the domain and range flip-flop. So the domain of this one will go from 0 to infinity. And the range on this one is going to go negative to positive infinity. Cool? All right, let's see. That one's going to be done the same way, so we'll move to the next slide. So let's go to problem number 9. Okay, so we have y equals log base 3 of x. So if you look at the domain of this, because it's log, I can't have log of any negative numbers or 0. But I could have decimals right next to 0, so I'm going to go from 0 to infinity. My range on this one, we can get pretty negative numbers out of it, so it's going to go from negative to positive infinity. And then flip-flop x and y. So I have a base of 3 right now. So if I did 3 raised to the and 3 raised to the, those cancel each other out, leaving me just, oh, that should be a y, excuse me. That should have been a y right there. So that'll give me an answer. Y equals 3 raised to the x power. And then with my domain, I can plug negative values in and get negative values out. My range, even if I plug negative values in, I just get values very close to 0, not equaling 0. So flip-flop your domain and range. Good so far? Uh-oh, notes on green fancy paper. Thank you very much. He's not here right now,
Okay.
so
Cool, thank you.
yeah, we'll.
Thanks. Was it Grant?
I was taking care of you.
Thanks, dude.
Yeah.
Who did that one?
All right, number 10, natural log x. Natural log can't be equal to 0, so it's got to be a rounded bracket for the domain. The range I could plug really small decimals in. Really small decimals in, and let's see. So, hang on, I'm just thinking. Someone get a calculator out real quick.
domains and 0 to infinity, is that what that is?
Yeah. Cool, thanks, man. I just had to double check something real quick. Cool, yeah, that's what I thought.
So natural x is like log to the 2.7 x.
Yeah, for the most part. Flip-flop x and y, or make it this, flip-flop x and y. The inverse operation of natural log is e. So I'm going to have both sides base e. So e raised to the, e raised to the. Those cancel. So it gives me e raised to the e, or y equals e raised to the x. I can, my domain and range are just going to flip-flop. Bless you.
Thank you.
And we get that. Okay. Let's see. Both of those are pretty common. So those should be set. This one you'll raise both sides 2 to the, so it looks like a lot like number 9. Those are the same idea. Okay. So, number 13, if you're looking at the negative log of x, that means the graph, rather than opening this way, will open that way. Okay? So I'm still going to be restricted on this one from, I can't have negative values, so I do a log of or 0. But my range on this one, it's looking opposite direction. Okay? This plus 2 actually will modify this. So this should have been a 2 because the whole graph was shifted up. Okay? And then the range itself, we're going to come from negative infinity, okay, because the graph itself kind of looks like this. We're going to come from negative infinity and get up to that point right there. So it's going to go up to 0. Is it going to be 0?
When is our test? Because
Thursday.
I was thinking Thursday.
So is it gonna be like massive?
Good news, I'll be here Friday.
I won't be here Friday.
Okay. So make sure you did get Thursday.
Orange Story Thursday. Wait.
I don't know.
What if we just don't have school for the next 2 weeks?
You know what it?
That'd be
pretty nice.
That would be a beautiful break.
Yeah.
That'd be boring to get out of school, so like, yeah.
I mean, we could all just leave. They can't stop us. I mean, I guess
Got
they
a
could.
point. You can't arrest all of us.
The kid does have a point. Just
Yeah.
Just as long as you run in separate directions. All right, let's graph this real quick. Y equals negative log x plus 2. Y equals negative log x. And then plus 2's outside. So zoom 6. Oops. Oh, shoot. I flipped it the wrong way. I flipped it the wrong way. Duh.
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 Dude.
Duh.
That's a flip, man.
This looks like this. So that's correct. And then it goes from negative infinity up to the 2. Cool. All right, so x equals negative log y plus 2. Subtract 2. Okay, equals negative log y. Multiply both sides by a negative. I'm going to get negative x minus 2 equals log y. I'm not sure why they left me all this room. So if I go y raised to the, and y, I'm going to go 10 raised to the, and 10 raised to the, bring this down here. I'm going to get 10 raised to the negative x plus 2, if I distribute that negative, is equal to y. And so my domain and range are just going to flip-flop each other. So the domain will go from negative infinity to 2, and my range will go from 2 to infinity. What would undo this one? E. So e to both sides, so e raised to the x minus 2 plus 5 will be my inverse. I'm just skipping over the domain and range right now, but a lot of times if you were to take a look at the graph, you'd be able to see it pretty easily. What would this natural log graph look like? It's going to look something like this, where we're going to kind of have this starting point that we're looking at, even though the graph's going to continue down this way. It shifted up 2 and left 5, but that shouldn't interfere too much. 15, 16 done the same way. All right, so the main thing that we're trying to get to. Remember when we did composite functions of each other? Like if I took a function and plugged it into itself. If I take an inverse and I plug it into its original, then the result should come out to x, which is the line y equals x. So this is the line that an inverse will flip over. Okay? And I think we can see that a little bit more as we progress on. So let's take a look at our first graph. Okay, so if I do this one in blue, if I plug 0 in, I get an error out. Okay, so that means it's undefined here. But if I plugged 1 in, that's going to give me, if I just hit log of 1 on my calculator, I'm going to get 0. And then if I plug, I'm going to choose to use 3. Why would I use 3 as a new plugin? It's base 3, right? Log base 3 of. So if I do this, it's going to give me an answer of 1. So 0 gives me an error. 1 I get right here. 3 I get right here. So this graph is actually kind of looking like this when we graph it. Okay. If I plug, say, 9 in, I'd get 2 out, which is right here, because 9 is 3 squared. So that's what's taking place with that one. If I do my other equation, we'll do this one in red. Things that are really just taking place on this one is the points you know all shift down to. So that's what those two different graphs would look like. Okay, and again, the shifts are the exact same as they have always been, okay? Everyone doing all right?
Hey, how'd you get 1 for 3? You plug in 3 for x and you get 1.
Yeah, because if I had log,
Oh, you know, I see that, yeah.
oops, log base 3 of 3, that's 3 to the first, which is just going to be 1.
Yep.
If I plugged 1 in, that's got to give us a 0 out. So that's why that takes place. All right. That's the same question? Almost. On base 3 of x. Oh, we're just going to shift it. Okay. So same principle on this one. 0 is the error. If I plug 1 in, I get 0. If I plug 3 in, I get 1. So I get this point here. I get 3, 1 here. If I plug 9 in, 9 is the same thing as 3 squared. So that'd give me right here. So this is what this graph is doing. If you know what the graph looks like of that, you can see what this is going to look like. That's going to shift which way?
Right.
Shift to the right too. So I'm going to take all the points that I know and just move them over twice. And then that one, I guess, like that. What I got? Is there a vertical asymptote? Yeah, the vertical asymptote would be the y-axis. Okay. The asymptote on this one, actually, I am off a smidge. So the vertical asymptote becomes this now, because everything shifts with that graph. Cool? Where are we at on? Oh, we're almost done, huh? Oh, that. All right. What is this blue? What do you think this is? Oh. Okay. Let's see if we can match that up. Okay.
Mr. Stirrup,
Yeah.
didn't you get these notes from the sub that you like?
Yeah, Mrs. Hogue.
She said she did them all fancy, and then you like didn't like. She did like all this stuff always, like the pullaways and like hidden stuff.
She did that. A lot of those things they cover up. That's her. I uncovered it.
Mr. Ormsby used to have like the weirdest noises just on his PowerPoint, right in the middle of like a new theorem and like,
My stomach often growls in class, so you know, I have weird noises too.
And one time it was just like Peter laughing for like 30 seconds from Family Guy.
So the line x equals h is a vertical asymptote. So this right here, this is going to be our vertical asymptote. And then the domain is h comma infinity. The range is negative, positive, infinity, which is great. And then the graph moves up to the right if our b value is less than between 0 and 1, and the graph moves down to the right. Okay? So there we go. This also moves it up and down. If it's positive up, negative down. And then that b value kind of goofs a few things up, so we have to be aware of that b value. Best thing with that b value is to figure out values that'll plug in correctly. All right, final slide. All right, write the log equation for the following graphs based on key points, vertical asymptotes, shifts, flips, and stretches. Okay, so looks like we're using this graph, and we're given the points 1 comma negative, or 1 comma 0. I don't know why I have a negative 0 there. And is that 4 comma 1? Okay, so what does my vertical asymptote appear to be in this case?
0.
So it's the line x equals 0. So that's my h value is equal to 0. And if I go back and take a look at that equation, we're going to plug it in. So that is y equals log base b of x minus h plus k. We know my h value, which is fine. And I'm going to kind of put a box here so we figure out that b. The x is going to stay as is. I can put in parentheses. My k value doesn't appear that it has shifted up or down at all because it's going right through there. This one will have a h value that changes because my starting point shifted up. But being I have 0, 0 right here, I'm going to have my k value be 0. So that's going to be a 0. Didn't move up or down. Okay, so how should we figure out that b value? Thoughts? We have 1, 0 and 4, 1 that are both xy points, yes? So I'd pick the simpler of the two. I'd pick the 1 comma 0 and plug it in. So I'm going to plug 1 comma 0 in, which is an x and that's a y. So I'm going to make that a question mark for right now. I guess we could make it a b value if we got fancy and wanted to stick with our notes. So I'm going to get 0 equals log base b, and my x value is 1. Okay. So what? Bless you.
Bless that.
Bless you. Actually, I'm going to pick my other point. What was my other point? 4, 1. Let's see what this is going to do. Y equals log base b of 4. So I'm going to flip this around so it's easier to see. Do you agree with that? So b to the first is equal to 4. So what does b have to equal? So my equation of that equation is going to be log y equals log base 4 of x. And that's my equation. We'll clean that up a little bit and look at the other one. Don't let me split my board anymore. Darn you. All right, so let's take a look at this one. So my asymptote, that's my h value. In this case, it looks like it's going to be -3. So if I plug a negative into the group, it'll be a +3, right? This moved up 1. So that's going to be my k value. And then okay, I think I can go ahead and say this. Okay, I know my k value has to be, or my k value is +1. My h value inside here is going to be x +3. I have log base b of y. Okay, so I have 2 values I could use. Why do those 0? I don't know why they have a -0 like that. That's kind of goofy.
It is kind of goofy.
-0 is 0, right? So we could do the 0, I guess. So 0, 2. So that's going to give me 2 equals log b we're looking for of 3 plus 1. If I wanted to start solving that to get my b value, subtract 1, I get 1 here. Flip it. So I can do this. So b to the first is equal to 3. So b equals 3. So then my equation is going to be log base 3 of x plus 1. Did we go 1? 3 plus 1. Is that right? What? We got it. We have to need to squeeze something in there. Squeeze plus 3 in there. That's a +3. That's an x +3 for those of us who can't see it. Cool? Yep. All right. Did anybody have old assignments?
Yep.
If you do, bring them on up and put them in the orange folder. Make sure your name's on them, please.
I have so many tomorrow.
Yeah, let's do it.
Let's go to Winter Park.
Yeah, baby.
Colin sick. All right, so worksheet J we'll work on for tomorrow. Okay, so real quick, the following folks, Landon, you know you have something to finish with me, right? And going through my thing. Olivia, you have the quiz 9A to do with me? Reminder when she comes in. And Grant, who's not here, he has something to make up with me. And Cooper, you have something to make up with me. It's 8G through M.
I really did just see it.
Blake, you have 8G through M to make up with me.
Yo, we took the same test, bro.
Yeah. So let's try and get that all made up before the end of this week. That would
Yeah, of course.
be easier because you know that after spring break, it's all
Not
silly.
gonna do any better. Take it.
Can you
You already
switch it
waited
out?
like 2 months.